In this problem, we're given n programmers and each with a certain skill level R. And we are given a list of m pairs such that these two programmers can't work together. And one programmer will be a mentor for another programmer if their skill level is strictly greater than their mentees. And for each programmer, given these restrictions, we want to find the possible number of mentees it can have. So if we just go to the very first example. So the first person could only possibly be a mentor to 4. However, number 1 and 2 cannot work together. Therefore, the maximum number would be it can have 0 mentees. Since this is the smallest number, this will also be the mentor to 0 people. Now this can be a mentor for 4 and they can work together. Therefore, this can have a maximum of 1 mentee. And this can be a mentor for all 3. However, 4 and 3 can't work together. So the maximum number of mentees the last person can have is 2. So first let's read in this information. So we're given a integer n and k, and now let's create something called skill, which is a skill for each programmer, and then let's just read it in for n, cn, skill I. And now what we can do is we can create a set because it's ordered, and what we can do is we can sort it in terms of their skill level, but we also have to be aware which person we're talking about. So we'll also save the index. So let's say in the first example, let's just copy this here. Cool. So the skill level, so it will be 10, 0, then it'll be 4, 1, but since it's sorted, this will be before, and then it'll be 10, 2, and then it'll be 15, 3. And why this is good is at any point, okay, let's first not care about the part about 2 people can't work well together. Let's just assume we can all work well. So at any index, like here, we know that this can be a mentor to the number of people to its left. So here, this can be a mentor of 1 person. This can be a mentor of 2 person. Oh wait, but it can't because they have the same value. So if they have the same value, then the maximum number of mentees this person can have would be the same as someone of the same value. So this is of course 0 because there's nothing to the left of it, or nothing above it in this case. This can be 1, and because these two are equal. Since these two are equal, the maximum number of mentees this person can have would be the same as this. So 1, and now for this person it would be the number of elements to the left, and since this isn't the same as this, it would just be 3. So now these are the maximum number of mentees these people can have prior to the restrictions. And now what we can do is, once we have these values, we can just look at these values and say, okay, out of person 1 and person 2, which one has the higher value? Okay, it's person 1. So we just take away 1 from person 1, and then that's gone. Now same here, we look at 4 and 3. Between person 3 and person 4, who is the higher value? Person 4. Okay, so we just take away 1 from person 4 because that pair is not possible. And our answer would be 0, 0, 1, 2, which is correct. Okay, so now we just have to do that. So we can just create we had a set of pair int, which I'll call S. And actually we can do it while we are getting scale as well. What we have to do is just we have to insert the scale and also the index. So that should be inserted as a pair here. Okay, so now it's going to be sorted, and so we want the number of elements to the left. Okay, so what we can do is we can create some integer, which I'll say elements to the left, which is initially at 0, right? And then let's just say our let's keep track of our previous pair, because we want to know whether this skill level that we're at is the same as the previous skill level. So let's just leave previous as 0, 0 as a backstop. Now let's iterate through all elements in this set. So we can just see if so we want to keep track of its skill. So we want to store these answers somewhere, right? So we want to keep track of the 0, 0, 1, 2. So let's just create some array which I'll call answer of the maximum value we can have is for n is 2e5, right? So let's just make that 1, 2, 3, 4, 5 plus some leeway. So that should be fine. So now if answer of y dot, so let's just let answer of y dot second, so this will be for that person, the number of mentees it can have would be the number of people to the left, and after each term we just increase number of people to the left, right? However, we're going to check if there is a pair. So if previous dot first is equivalent to y dot first, then the answer of y dot second is equivalent to answer of previous dot second. So the number of mentees for both people of skill levels should be the same. Yes, otherwise we do this. That makes sense. And once we do this, we have to change previous to our current one. So previous dot first equals y dot first, and previous dot second equals y dot second. And then we increase the number of elements to our left. And I think, yeah, that should be right. And now we're given k pairs that don't work. So we're given A and B. And everything we do here is going to be 0 indexed, and our A and B is 1 index, so we just have to make it 0 indexed quickly. And now now we're going to check if skill of person A is greater than the skill of person B, then we have overcounted by 1 for person A, so then so we do minus minus answer of A. And in the same logic, if it's the opposite way around, then we decrease the answer of B by 1. And then if they're equal, we never count them in the first place, so nothing ever happens. So then we just have to go through all of the n possibilities in answer, and we just see out answer I. And that should be good. Where? Oh, I didn't even get them in yet. Okay. C and A and B. Okay, let's check if F works. So 0, 0, 1, 2. Perfect. 5, 4, 0, 5, 3, 3, 9, 0, 2, 5. Perfect. Okay. And now we can submit. and voila.